Good afternoon. Can you all hear me correctly? Please say so in the chat if you want. We will start in a couple of minutes. It looks like everyone is connecting already. Okay, it's 5 minutes past our starting hour. So in case anyone can't hear me, please let me know through the chat so maybe we can do something about it, on the technical side of things. And once everyone's ready, we will start with our webinar today. The topic for today's webinar is CYPE and its structural solutions for architecture, construction, and engineering. I'm David De Dios. I'm a support technician for CYPE for quite some time now, and I'm also as well an architect. So that means that I'm both well versed in what's all about our software as well as what our software is being used right now on the street. So without further ado, let me show you a brief introduction of what our company is about and what our programs can do for you. Okay, here we go. CYPE is a company that has around 38 years of experience. We were founded in 1983 in Spain, and right now we have up to 150 applications available for all your structural and construction needs. We have more than 30 resellers all around the world. We started expanding in the 1990s all the way to nowadays, where we're starting to gain a foothold around Asia. And we have more than 200 professionals at your disposal to attend all your needs and to develop our products. Right now, we have around 140,000 active users each month, and we are research intensive in this degree. Our industry is all about BIM, building information modeling. What is it all about? When we're talking about BIM, we're talking about tendency, fashion that's happening right now all around the construction and engineering world, and it's all meant to try to integrate as much information into a model as possible, so multiple disciplines all around architecture, engineering, and construction can work at the same time, and as well share information and moreover be more productive, because sharing this information helps us understand the overlaps between all the information that is contained inside a project, and helps us moreover try to integrate it and turn it into something more powerful for our experience. So what we are doing is that we are turning 3D modeling into digital construction, a digital twin, if you will. And in the process, what we're doing is that we are increasing our productivity. A BIM project is normally made of different pieces, as you can see here. We would start first with architectural modeling. We have many programs around the world that can supply this first part. Then we would continue with software for calculation, analysis, and design, like ours. Another integral piece of a BIM project is interoperability with other databases and with other programs for visualization and so on. And last but not least, databases are as much as important to generate final reports and our budgeting. This is what we mean when we are talking about Open BIM project. We're talking about more than 200 regulations that are implemented into our products and that allow us to work with our software like SAP Architecture for our architectural modeling, or BIM Server Center, our main switchboard to share all the information that has been generated with our programs and more programs from all around the world, as well as OpenBIM Systems, that is the main relationship that we have right now with most developers and most product designers that work with our programs. So what we're talking about is an OpenBIM workflow. That is a workflow in which all programs are independent from each other and only the data is the most relevant. That is, the data belongs to the project, not the project to the data. And we can achieve that through standards such as the IFC file format. With the IFC file format, what we have is a model that is itself composed with each and every different IFC file that comprises different discipline of the construction of the building. So what we are having in the end is a federated model with many different layers of information that are intertwined. Here's an easy example. For example, we would start with a structure, and then on we will go adding more and more layers of information like plumbing, electricity, HVAC, home appliances, furniture, exteriors. All the while we have this very complex project, this very complex file that at the same time saves us time and money, because we're sharing at the same time the same information for all the different disciplines and all the people that are involved in the development of the construction from start to finish. Let's not forget that most of the time when we talk about this kind of software, we think about software it's only used for the design process, but really all these kinds of software can be used throughout the life cycle of a project, all the way to its end of life analysis and cost maintenance, etc. Right now, inside our offices, we have different new projects that are being taken into development, like, for example, within COVID-19, for the situation that we have right now with the pandemic, Stream River and Site Connect Steel for your structural needs requiring steel for all kinds of regulations from all around the world. The SWAP Fire for fire protection, open accessibility, CYPE PV systems. Now that energy efficiency is more than required in each new promotion of buildings. Open sampling for all your needs relating to documentation and so on. And last but not least, what I was talking about before, all the continuation work that happens with work safety in the construction field and so on. BIM Server Center is basically our switchboard, our hub for all the applications and all the IFC files that can be shared between all the different actors in a construction site. You can see in real time the development of your project, taking into account that you can either follow it through your mobile devices, through augmented reality, and even through virtual reality at all times. It doesn't matter which device you're using to follow the development of your project. You can see in real time how your federated model is starting to grow and how all the different files are being shared and are being developed on. As you can see, it's a workflow that basically works in synergy with all the different disciplines of construction. And we are not talking about a static model, but instead of a changing model that is adapted regarding all the different changes that happen in the fields of architecture, structures, and building facilities. With BIM Server Center, we also included an app store that allows you to integrate as many different softwares as you may like to carry on the development of your project, from structures all the way to visualization. So up until now, we've been talking about architectural modeling, simulation analysis and design, detailing and manufacturing, and consolidation, model checking, and graphical representation of our end result. Now let's see how this would go forward in BIM Server Center. We would first start with a model made by an architect, and then he or she would upload it in IFC format to BIM Server Center, and then on the engineer responsible for structures could start working on top of that IFC file and then develop a structural solution for that specific project. Then the architect will be able to have the IFC file containing the structure and make all the defining changes that are needed to comply with the standards. Then he would upload the final result of this adjustment, and this final IFC file would be shared all around the different engineers alongside the structural ones to start developing and analyze and have a final solution for all your installation needs. Then once they finish their part of the project, we will have all the documentation necessary in BIM Server Center to then share it with the administration and the building company to start constructing the project in itself. We are offering a workflow that is very flexible, and that it all starts with a physical 3D model with a digital twin, if you will, of your project. Or you can do so with one of our tools like IFC Builder or the newly released CYPE Architecture, or in case you're working with other tools like Revit or other ones like Allplan or ArchiCAD, you can export your files into an IFC format that can be understood by the rest of our programs. The normal workflow with Revit would be as such, with a plugin that we have developed, so you can directly export all your modeling into Beam Server Center, and then on all the different applications made by CYPE can read that information and work on top of it. Same thing would go with ArchiCAD, with the only difference that instead of using directly a plugin, you would need instead an IFC translation that is integrated into the program nowadays. And now that we have got the hang of what's the theory behind all our development, let's see a brief case study to see how this applies in the real world. This is in Temple building. This used to be the tallest residential building in Europe and was finished in 2006. It's around a half-hour's drive from our headquarters, and it was entirely developed with software made by CYPE. As you can see here, we have the different plans and elevation sections, constructed details that have been generated with the help of our programs. And to the far right, you can see the digital twin, the beam model that we were talking about that has been generated with CypCAD. As you can see, we're talking about a quite serious project, a project that really certifies the power of our programs. And we're talking about a project that has been generated from top to bottom with our solutions, to the point that combines the different strengths and weaknesses of our programs to integrate different kinds of structures, like this singular structure that we're seeing right now of this upside down cone that has been integrated into CypCAD with a structure that has been made in steel with Cype 3D. And then last but not least, I'd say that our major seal of approval is the city of Benidorm itself. It's the city with most skyscrapers per capita in the world. And what you're seeing right here, more than half or you can reach for has been made with CYPE. Thank you very much for your attention. And right now, if you allow me, I'll show you a brief overview of our programs for your structural needs. Have we got any questions up until now? Okay, now let's switch to a brief demonstration of our software. So when you first download and install our programs, what you first get here is the CYPE menu. CYPE menu is a basic hub where you can have all your different applications at the same time. And as you can see here, we have them structured by disciplines. We have structures, MEP, management, documentation. In our case, we have the structural tab here with CypCAD and Cype 3D, which are our main programs for structures. But then at the same time, we also have other programs that you can use in conjunction here in Beam Server Center. And you can share all your progress with the services that I was talking about before for your projects uploaded in IFC formats. So let's start, for example, with Cype 3D. As the name implies, Cype 3D, it's meant to work in 3 dimensions, and it allows you to work in a free flow manner. For example, this is a project that has been done with Cype 3D, and as you can see, it's a quite singular project because it's basically a sculpture, integrity structure that doesn't comply with what you would expect in your traditional development of structures, working with plans and elevations. So let's try with an empty project for now, and let's see what are the capabilities of this project. We can start with an empty project, or as I said before, we can start with an IFC file that we have generated with CYPE architecture or other programs. And once we start, we can set our technical code. We have building codes from all around the world, as you can see here, and the list is ever growing. Let's set it by default right now. And as you can see, we can set all the different materials that we can use for raw steel, cold form steel, timber, aluminum, concrete, and so on. And for loads, we can use different additional load cases as well as dynamic analysis with earthquake and wind situations in regards to the technical code that we have selected here. So let's start. And as you can see, we're greeted with this window that works mostly in 3D. And the main philosophy behind Site 3D is working with nodes and bars. So what you would do normally is to start setting nodes, for example, or instead you can start with bars. And as you can see here, we can set different types of materials that are preloaded by default. We have, as I told before, cold form and rolled steel, timber, aluminium, concrete. And in case we don't have the section series that you're looking for, and as you can see, we have many built by default, you can create your very own right here with the section geometry and mechanical characteristics here for your generic section. So let me show you very briefly how modeling would work. We work directly in 3 dimensions with the help of some auxiliary lines like the ones that we're seeing right here. And as we progress in our modeling task, we will be able to add things like the relationship between all the nodes, all the different loads with their load cases, and so on. Now I've finished the introduction of a very basic structure right here. And now what I'm going to do is I'm going to set all its basic properties for it to interact and arrive to a final calculus. So, for example, let me pin it to the ground first with external fixity right here. And once we have it, let's add some loads. For example, with panels, we make a panel on top of the nodes that we have here. And once we have it ready, what we have to do is to set which load case is going to work on. For example, like this one. Now, once we have it, we would be able to analyze it. And once we have it analyzed, we will see all the different checks and comprobations that the program has done internally. As you can see, of all the bars that I have inserted, the ones that are in red do not comply with the technical code, so there's no problem whatsoever. All I have to do is check for the nearest value that is compliant with the technical code, and once I have it already, I can generate my unions. And once I have my unions here, let's generate the unions. And once I have my unions, I can finally generate my reports and my drawings. This is one of the main strengths of our software, and that is that it can generate reports and drawings automatically depending on what you have inserted here into the modeling space. So, for example, let's generate now very briefly a simple report like so. And as you can see, the report contains all the internal calculations, all the quantities, and all the specifications, all the comprobations that we have put forward in our modeling. Once we have it finished, we can export it into a PDF file, or we can share it through HTML in an attached file, or we can print it, or we can send it by fax, etc., as well as all the kinds of reports that you can generate with the different programs made by CYPE. Once we have our report ready, we can generate automatically drawings with all the different things that we have inside of our modeling space. Let's add some unions, for example. And once we have it, we would have something along the lines of what I'm going to show you right now. I've already generated the drawings, so let me show you how it would look like. You can generate them directly into AutoCAD, or you can print them, as I told you before, in PDF or other formats that you can print and share in an email, in an attachment, and so on. Now, meanwhile, let me show you another project inside this program to show you the full potential of CYPE 3D. This structure right here is meant to show you which are the strengths and weaknesses of CYPE 3D. As the name implies, it's meant to work freehand on a 3D space without talking about the floors, sections, plans, elevations, and so on. And you can achieve things like this. A structure that is not compliant with what you're expecting in this kind of structure, something reticulated, something orthogonal, 90 degrees. In fact, this structure has been directly modeled inside CYPE 3D, but in case you were to treat it with other programs like Rhinoceros or Grasshopper, you could generate a DWT file that you could later import, and from then on, with an assistant or either by hand, you can transform this to a model that can be checked one by one, all the different sections of all the different elements that comprise it, like we did before, with all the respective calculations and all the checks and balances that are according to your specified technical code. This can also be inserted into the report that I was talking about before. And as you can see, it's very thorough in all the different comprobations that you must comply with the technical code. Okay, the drawings are loading, so meanwhile, let me show you what CYPE is all about. CYPE is the two-dimensional cousin to CYPE 3D. They are meant to work in tandem. So let me show you here overall how CYPE works. Well, now the drawings have finished loading, so as you can see, this is what normally you would get automatically out of your CYPE 3D or CYPE project with the click of a button. A file that contains as many drawings as you can with all the types of details already generated, so you can save much time and effort, and you can gain much more in precision and definition of your final results, like what we're seeing right here. And as you can see, it's a regular DWG file, so if you feel you have the need to correct or modify anything of what you're seeing right now, there's no problem whatsoever to do so. Okay, let's switch to CYPE and let's see the difference between CYPE and CYPE 3D. As I have told you, both CYPE and CYPE 3D are meant to work together, so it doesn't matter where you start. As I've shown you before at the beginning of this meeting, we don't force a standard workflow in your company. What you're doing is that we are giving you a vast variety of the different workflows that you can combine and work with as you seem fit. So now let's start with a new job here in CYPE. And when we start a new project, we can start with a BIM model in case we had something already generated in BIM Server Center, like I've showed you before. In this case, we can start with a new job that could either be an empty project or that we could import with something that we have done previously in CYPE 3D with an IFC file that has been generated with another program, or with an automatic introduction of a DXF or DWG file, provided that you have before set different layers for all the contents of your structure. Let's start with an empty project. And let's see the differences with the structure that I showed you before. As you can see, the interface is practically the same. I'm going to set the same codes as before. I'm going to do the exact same for the loads with wind loaded and with seismic loading. That, as you will see right now, both wind loading and seismic loading both have the different technical codes from around the world, and you can check them in real time with all the help that is integrated into the program. So you don't have to have a physical copy or another tab open with your technical code. You can directly access it with the chapter that is most relevant for every window that you are using at the time. So I'm going to leave everything by default. And we're going to see right now which kind of workspace we're going to have. As you can see, this is vastly different from what we have seen in Site3D. In this case, we're working all the time in a 2D view, and instead of working in just one tab, what we have is different tabs for different elements. So we would start first with our vertical elements, and then we would switch to horizontal elements with beam definition. And then once we have everything finished, instead of working directly on the 3D model to check all the different results, what we would do is that we would switch to the results tab and the contour maps to see which elements comply with what we have set in the requirements, and how the strengths, the efforts inside the structure are working. So let me show you real quick with the same file that I've used before, how it would look like in a two-dimensional workspace, like so. I'm importing templates. This is one of the main features when we're working with CYPE. We can work with templates generated with AutoCAD in DWG or DXF, it doesn't matter. And as you can see, we have the same structure that we have seen before, but in this case, in a 2D projection. So now that we are in column definition, we could start defining all the vertical elements, first setting floors. In Site3D, it doesn't matter if you start with floors or not, because it's a more freehand 3D experience. We would start with 2 floors, for example. Very different in each category and live loads and dead loads, as you can see. And once we have them, we can start setting our vertical elements, our columns, that is. We can snap them with the template object snaps tool to the template that we have imported that has been made in DXF or DWG, like so. And the program will automatically set your element to the insertion point that you find most comfortable. In this case, it starts with by default in the center, but if I were to set my cursor a little bit to the side, it will automatically interpret that as a different way of inserting the element with its reference point. So let's say that I have finished inserting all the different columns, and once I've finished inserted the columns, I can set its initial final groups, like so. In this case, we're going to set them all to the second floor, and I can set its external fixity, that is in relationship to which kind of foundations we're going to use. We will see this later. And now, so we can have a SPT meeting. I will show you how the vertical elements would look like once we have inserted them all into our column definition tab. Here we have the columns, and you will see now that if I turn off my template, we have also auxiliary lines, and we have all the different elements inserted with the criteria that I was talking about before. Now let's switch to beam definition, and you will see what I was talking about before in regards to floors and the 3D view. The 3D view here in CYPE is mostly informative. It's not something that you work directly on. And as you can see, all the vertical elements that I inserted before are now aligned with the starting and finishing levels that I defined. So now that I'm here, you will see that on the bottom right corner, we see on which level we are starting to work. We will go first down a group to the foundations, and let's start with the foundations. We could start, for example, with pad footings, but for this kind of structure, I would recommend to work first with a foundational slab, with a mat slab. So to do so, what we have to do first is to define a non-structural beam around it. Here we have a non-structural beam. We have many kinds of beams that we can work with inside the program. like flat beams, drop beams, lattice beams, beams with external fixity, press beams, foundation beams, and steel and timber beams. This is what mostly differentiates us from the competition, and that is that we work internally with the same software, with the same calculus engine for all these different kinds of elements. So it doesn't matter which program you're using, because at all times you will have a very wide selection of materials to work with. So in this case, I'm going to select the non-structural or limit beam, like so. And in this 2D view for the foundations, I'm going to define the limits of our foundation slab. As you can see, it's very quick and easy to do so. And now, once we have all our beams defined, we will have a question mark that is asking to insert our panels. Something like what we have done before inside 3D, but instead of freehand, we have a physical border that is defined with a structural element. Let me fix first this thing right here. And once we have it, we can start defining our slab with a panel manager. Just like we did before with the beams, as you can see here, the panel manager, we have many different kinds of constructive solutions for all the different floors that we're going to introduce. We have joist floor slabs, hollow core slabs as well, composite slabs, waffle slabs, flat slabs, mat foundations, and a generic definition in case we don't have your specific construction solution. Most probably we will have already preloaded the kind of panel that you're going to use, because we have many different kinds already preloaded, like in this case for waffle slabs. You have some libraries already loaded, and in case we didn't have your exact library ready, you could create your very own, like here. You can add your very own, or you can work with ones that are already preloaded, like this one. So what I'm going to do right now is that I'm going to set my foundation, set which kind of precision situations it has, that is, which kind of soil is on top of. This is another thing that differentiates us from the competition. We have a engine that treats all the different aspects of the calculus, from the soil all the way to the foundations, going up the structure to all the discrete elements that we could add. So for example, let's say it's on top of loose sand, like so, and let's insert it by selecting the panel that we have defined with our beams, the direction, and that will be it. Now, if we go to the 3D view of the building, you will see that indeed now we have our foundation slab. We have our mat foundation right here. Now let's jump, for example, to the next level. Let's jump to floor number 1. And here we can do exactly the same, but instead of working with foundations, we work once again with beams. We can work with walls as well if we wanted. We can put retention walls like this one, like we're showing right here. Or, as I said before, we can continue with the definition with beams. Let's put some beams that are flat beams, like so, 50 centimeters wide, for example. And let's define the limits of our slab. We can have straight edges, but at the same time we can have non-conforming edges, and we can also work with curved edges, like so. Okay, let me set everything straight. Let's define this void right here very quickly. And once we have our void defined with the bounding elements, we will do exactly the same what we have done before with the mount foundation. It's the exact same logic behind it. So what we have to do is, once we have everything set up, we have two question marks. So we go to slabs, panel manager, delete panel, so we can put an opening here, and define panel. We are greeted with exactly the same thing as we did before, and we're going to work, for example, with waffle slabs. Let's load the library, like this one, for example, and once we have it, we can generate the drop panels automatically. If we go to slabs, drop panels, generate drop panels, and we have automatically generated all the drop panels. And now let's say that we wanted to put another hole, another void into our slab. That would be as easy as either doing what we did before with this void, or we can also insert it with introduce openings, setting the kind of bin that we're going to use as a bounding element. And there we go. We can insert as many openings as we want, like so, and it automatically will set it up so we don't have to bear in mind how it's going to work later in the calculus engine. So another of the elements that we can insert into the bin definition is stairs. Stairs are also treated as if they were a structural element, and indeed you can try and get out all the different drawings that contain all the reinforcements and the meeting points with all the structural elements and so on. You can configure as many different kinds of customizable flights of stairs, like this one, for example. And once we have it, it's as easy as dropping it where we want it to be, like so. And it is already loaded into our 3D model. Let's switch to the 3D view to see what we have done up until now. As you can see here, we have the stairs as a structural element with all the drop panels already generated, with all the beams as bounding elements, and so on. I won't bore you with more details, and I'll show you the end result of this structure with an array generated, another project that I have here in the background. Okay, so this would be the final definition of our structure. Let's switch to the 3D view, and we'll have something like this. Now, if you remember the structure that I showed you before in Site3D, I didn't show you that structure for no particular reason. What we're going to do right now is I'm going to show you how you can import structures that you have done in Site3D into SiteCAD so you can combine both workflows. As I told you before, we do not recommend one single standard workflow for everyone, but instead we give you full freedom so you can work as you like in your office. Okay, so let's jump to the final floor and let's insert here our integrated structure. Import job from Site3D. And now we will be able to see a menu that will allow us to insert it on top of our existing structure, like so. As you will see right now on my cursor, we will find the inserting point for the structure. And what we are going to do is that we are going to center it into the axis of one of the pillars, of one of the columns right here. We have the structure already pre-generated with all the stresses and all the sections, all the unions already generated in Site3D. So with just a click of a button, we have already combined two very different technologies at the same time. Now, once it finishes loading, we will see how it looks like in our 3D model. As you can see, once you have all your projects ready, you can export them into BIM Server Center, and you can also get a 3D view of the element, like the one we have seen before. This view is at the very same time comprised of different IFC files that can be uploaded at the same time, like the one that we could generate right now in CyPCAD or CYPE. Okay, now that we have this already set, let's switch to the 3D view and let's see how the end result looks like. Great, isn't it? We have two very different technologies working at the same time, working with the same engine and taking into account the same efforts for all the integrations that we're working on. So once we have everything set, we can switch to the analysis of this project with the Analyze tool, including the foundation. I've already analyzed this project in another file, so let's switch to it for brevity's sake, and let's see how the final results would look like here in the Results tab. Here we have the end result, and let's see what can we do with it. As you can see, CyPCAD is perhaps more modulated, more straightforward than CYPE in cases where we want to work with two-dimensional planes like residential or commercial buildings. So let's see here in the Results tab what we have got after analyzing our project. We have the same 3D view as before. And what we will see right now in the elevations and the sections is how each individual element complies with all the specifications that we have set in the technical code. As you can see, if an element is in red, that means that it does not comply with all the specifications that we have set in the beginning. And in case we wanted to switch them one by one, all we will have to do is go to the appropriate menu, like for example, columns, edit, and you will see that the program has automatically paired all the different columns in regards to how they all work. For example, here we have the same comprobations, the same checkings for this kind of column. And as you can see, it's quite straightforward. It gives you a summary of the code checks, and it goes quite into deep into all the different comprobations that you are required to do by law. You can see that it takes into account all the different combinations right here, and you can get an individual report for all the different comprobations that the engine does internally, like what we have seen before in Site3D as well. You can export this as well into a report if you want later. And in fact, we're going to do this. Now that we have seen how the final results work, let's see how we could generate reports and drawings like we have done before in Site3D. It works exactly the same. With the reports, we can generate a default report, or we can create a customized report. As you can see here, we have some reports already preloaded with things like, for example, the checks, the beam quantities, the reinforcements, and so on. Or in case you want to do your very own report, you can create it with all the chapters that are available here. And just as adding them into this left column, you will have your very own report with all the chapters to your liking. So, for example, let's generate one right now. And because this takes quite a long time, I'm going to show you what the end result would look like right here. I've already exported the report into a PDF file like I did before in Site3D with the other project. And you will see that both programs work exactly the same in regard to reports, drawings, etc. I'm going to prepare as well the drawings so we can see them later in AutoCAD. And here we have the report of this structure with all the different calculations, diagrams for the internal forces, all the checks that have been done internally in the program and can be exported and then added to your final report, so you can get your seal of approval inside your company or with the administration for your country. And for the drawings, Same thing applies as we have seen before. We have the drawings tab right here, and once it generates all the drawings, we will be able to put our very own title log, so it automatically adds it to all the different drawings. And we will be able to generate different drawing types to our liking, like for example, layout plans, column schedules, the change of columns, steps, because they are also a structural element, as I told you before. And same thing goes with the title block. You can automatically integrate a title block into your sheet, so there's no problem whatsoever. Let's save all the changes and see how the different sheets would look like. It takes a little while, so please be patient. And let's see if in the background AutoCAD has already loaded the files as well. Okay, we already have it. Now let's see which drawing composition the program has automatically generated. This is what we are going to see right now that has been generated inside CYPE, and this is what you would have once you export it into DWG. And just like with CYPE 3D, you can export into a native file and you can start changing and modifying, customizing your drawings to your liking with all the measurements and all the technical details of each element already generated by our software, like so. You can see here in the drawing compositions tab that we have exactly this very same composition right here already exported. And now that would be a very brief overview of what CYPE and CYPE3D are able to do. But this is just the beginning because, as I've said before, we also have BIM Server Center, which opens a myriad of possibilities for the project. And in fact, right now we have launched to the market some projects that can be an accessory to these programs, like CYPE Connect Steel, which is meant to create singular unions between different construction elements, or like the StreamBeam series that is meant for more concrete analysis and a more individualized workflow in case you wanted to have multiple engineers working at the same time with the same project. That's the beauty of the BIM infrastructure, that you can have multiple people working at the same time on the same project without being a nuisance between each other. So now, just for finishing our main demonstration, I'm going to show you one of these applications that is available here in BIM Server Center, and that is CYPE Connect Steel. And I'm going to show you how it works with the building that I've shown you before at the beginning. Let's open CYPE Connect Steel. Let me first close some things in the background so everything goes smoothly. As you can see here, we have the bar to export to BIM Server Center. And in this case, what I have done is that this very same building, I have exported it. I have linked it to a project and I have exported it to a project. And then when I have started a new project here in CYPE Connect Steel, what I have done is I have linked it to a new project in BIM Server Center, like so. Here I have, for example, this project right here. And as you can see, it has the IFC files I have generated with CYPE and CYPE3D. I'm going to import the one that I have done with CYPE. And once I have it, I can start working on all the individual unions that are meant to be worked with inside CYPE Connect Steel. CYPE Connect Steel is a program that works with the OpenSys engine. That is an engine that has been developed in collaboration with the University of Berkeley, California. And it's an open standard that it's not exclusive to CYPE, but instead it's something that is meant as a standard to be adopted all around the industries around the world. So once we have our project already loaded here in CYPE Steel, we will see exactly how the unions are defined inside this project. So let's wait a little bit so it loads the project, and let's start working. Let's see, meanwhile, if we have any questions in the chat that we could answer. Okay, so let's continue with CypConnect Steel. And once we finish this very brief demonstration of CypConnect Steel, we will be able to answer all your questions in regards to all our products, and we will finish this meeting once and for all. Okay, we have our project already loaded. As you can see, it's the exact same structure that I've shown you before inside 3D. And we can go node by node, designing how the different unions are going to work in a manner that goes for each individual element. So later when we do the final calculus, it goes with the final, with the finite elements, with the final elements modus operandi that we are accustomed to here at CYPE. So for example, let's set which code we're going to use here, the Eurocode, for example. We have many kinds of libraries of sections like the ones that we used before in CypCAD and in CyPE3D. And once we have everything set, we can go to this specific connection and we can start defining all the different steps to define this union. As you will see here, we have a tab to the left where we will start stacking all the different operations that are going to be taken into account to define our final union. We can start, for example, with a plate operation for this panel right here for V3. We are going to set it as an attached M plate to V3. Like so. Or in case we wanted to completely trim this section, we can directly edit it with an end plate, like so. We're going to set it, as you can see, this is very flexible. You can set up to the millimeter what you want to do exactly at each time. So in this case, what I'm going to do is I'm going to set this front plate to the bottom flange, and it has automatically set all the different meeting points between V1 and V3. I can change the properties of this front plate in case I'm not content with them. So I could add some overhangs, for example. And once I have it, I can set the weldings for all the individual parts of this section, like so. If we go to weld, we can define with much precision what we want to weld to which part. So in this case, I'm going to take the top flange and I'm going to weld it to this plate. And as you can see here, we have the weld already generated on both sides of the top flange. We would do the very same for the web on the bottom flange. And now let's see, for example, how we could insert this profile section V2 into V1. CypConnect Steel also has bolts and plates, so we can make unions that are not welded, but instead are articulated with bolts. And that's what I'm going to try to do right now. So I could trim section V2 with the trim action right here. Let's set the position and which kind of trim we want, like so. Let's do the same, for example, let's copy it and do the same for the bottom. And now what we have it, what I'm going to do is I'm going to add some plates here in section V2 so I can do this articulated union with bolts. Okay, let's add the plates. And here the plates, as you can see, can be articulated as attached plates to the section V2 into its web, for example, like so. And the beauty of CyPE Steel is that it's so flexible that you can add as many pieces as you want of plates. In fact, I've seen projects where people have gone completely crazy and added lots and lots of plates and bolts and welds, demonstrating how powerful this kind of software is when you have this very kind of specific needs. So I'm going to do the same. I'm going to copy this plate and put it on the other side. Well, first I'm going to displace it a little bit to the right here with displacement. I can displace it freely in all the 3 axes of degrees of freedom, like so. Now let's copy it and put it on the other side on the back face, like so. And now let's try adding some bolts. As you can see, bolts are another type of element that can be loaded into different libraries in regards to which constructive elements are used in your specific project. But we have some already built by default, and you can put them in many silly places, like what I have done here. Let's put it to this plate, for example, element, plate, plate 1, and we're going to bolt it to this plate, like so. There you go. Now we bolt it to the section, like so, on the web, and there you have it. We have our section already defined. Now I'm going to show you this very same union, but with all the welds already defined and with this particular union already analyzed, so you can see where the strengths and all the different internal forces of this union work and how efficient our design is. So let me show you right now real quick. I'm going to show you the file which has all the final calculations already done. This one right here. Let's hope it's quite faster this time because we're not importing. Don't be afraid to ask any questions. We will have later a session for questions and answers. So okay, it's already loading. I'm loading this file precisely because I want to show you exactly what is the final result after we analyze it, because depending on the difficulty of your union, it could take quite some time to get to an accurate result. And just like we have seen before with CyPE and CyPE3D, this kind of final results of this analysis also gives you a very detailed list of all the comprobations of all the checks and balances that are according to your technical code. This is the union that we were talking about before. Let's edit it. And as you can see, in this case, I've already added all the different add-ons, all all the different welds, the plates, and so on. And now, once we have this finished, we can switch to the analysis tab. In this case, all the efforts, all the internal efforts, all the forces of the model have been imported directly from CYPE, so we don't have to manually calculate anything. But in case you wanted to override what you have imported from CYPE or CYPE, you could go here in the load cases tab, and you could create your very own load cases with different kinds of loads and all its combinations, like so. You could make, for example, you could turn all the different elements into bearing or non-bearing sections, and then you could also create your very different discretization sizes, so you can work with a more precise model, for example. You can start, instead of working with triangles with 50 millimeters of sides, you could work with a more discrete, more concrete solution. And in regards to the loads, as I said before, you can set as many different load cases with all the different tolerances and iterations as you want. So in this case, I've already analyzed, and here we are seeing the final result, which is the maximum usage coefficient of each piece. As you can see, most of our elements work correctly, except these bolts right here that are in red because they exceed the maximum recommended strength. And we could also see the von Mises stress at the same time. This is what I was talking about before, the discretization. We're working with triangles each 50 millimeters wide, but in case you wanted to get more concrete and more precise, you would work with very minimal triangulations of this section. And as you can see, we're working with the maximum and minimum efforts that are required, that are recommended for this kind of section here in megapascals. We can also see the deformations as well. As you can see, this piece doesn't really deform that much. It doesn't deform more or less half a percentage or even 1%. And last but not least, we can see the displacements as well in millimeters. As I said before, once we have got our analysis and our results ready, we can get reports just like we did before in CyPE and in CyPE. And this report with all the checks goes quite into detail and shows you all the different checks, all the different comprobations that you have to take into account, and which ones comply or not. In this case, for example, if we switch back to the results, if you recall correctly, we had those bolts that do not comply, and here we have exactly why they do not comply. Distance between centers of fasteners. So now that we know what are the values that we had to take into account, we can manually change them and then reanalyze our project and export all the different checks that we have here, just like we did before, in a PDF format or into an attachment for an email, or we can send it, for example, with a fax, or you can print it, etc. So this would be a brief overview of what all our software is capable of doing. And this is just the beginning. We started as a structures company, but right now we have solutions for all the different kinds of disciplines and all the different agents that are involved in the construction of a building. So I would advise you to start on your own on all the different programs that we have. You could start directly into CyPE or CYPE, or in case you feel more adventurous, you could directly switch into CYPE architecture, which is free of charge. And you could start there with an architectural definition of your building, and then you could export it into BIM Server Center, like I've showed you before, here. And then you could start trying either importing it, for example, into CyPE, which I have already done here with this project, or you could try with other programs to see which are the needs that CYPE can effectively cover for your company. So I'm going to show you, for example, how this file in CYPE architecture works in CYPECAD, and this meeting will be over and we will switch to questions and answers. Don't be afraid to ask any questions. Okay, as you can see here, we have our 3D model of the building, and we have inserted here into the architectural tab in vertical elements all the columns, and on horizontal elements we have inserted all the floor slabs. So this, if we were to export it into our project and we were to start a new project in CYPECAD, for example, we would have already all the definitions of all the elements that we have here in the beams and columns. Let me show you. See, once we were to export our project, we will get all these columns and all these floor slabs. I've already done this in the background, so I'm going to show you how it would look like more or less once we got it into CYPECAD. Let's open here the menu. Let's fire CYPECAD. And I'm going to show you how it would look like once you have it imported from BIM Server Center. Here I have the import already done, and you will see that both in the beams and the column definition, I have already most of the elements inserted. And if I were to switch to the 3D view, you will see that most of what we have inserted here in regard to the structure, beams and columns and floor slabs and so on, has been imported as a native element in CYPECAD that you will be able to analyze and treat according to your needs. This and much more is what really differentiates us from the competition. For example, we did a study quite some time ago about the differences of our internal engine in regards to other software, like for example, ETABS. And one of the things that puts us forward in comparison to, for example, ETABS, is that our engine is quite more accurate in a sense that you can get values that are 5 to 10% more accurate to what you could get in ETABS with comparisons as simple as just one porticated structure or something as being as a 10-story building like this one. And as you can see here in the final results, we get differences of up to 10% in regards to efforts. And these differences in percentage between the two programs are also later reflected into our final result, because we can create structures that are more lightweight, easier to put into practice, and overall cheaper both for us and for our clients. Another thing that differentiates us from the competition, which could be, for example, StatPro, that would be the vast catalog of elements that we can work with inside CYPE. We have many things that StatPro and StatPro Advanced doesn't have, like, for example, quick and primary optimization of the sections, which is by default activated in CYPE 3D. So you can only start developing the overall view of how your structure is going to look like, and then CYPE will automatically generate all the sections in regards to all the loads that you have put. If you recall correctly, what I did before in CYPE 3D, I did not waste much time selecting all the different kinds of sections that work. Or for example, more things that differentiates us from StatPro is the detailings of the loadings or of the modeling. We go pretty much into deep of what you are working on the project on real time. As I said before, our very vast catalog of products also allows us to have things that the competition doesn't have, like pre-stressed beams and slabs. Very important when you're working with steel structures. And when you're working, for example, with concrete structures, we have comprobations and checks that SAT-Pro doesn't have, like punch and shear check and other kinds of interactive design elements. And last but not least, we also work with composite elements now that they are more common than ever. The interaction between steel and concrete, as I told you before, works all streamlined into the very same modeling program and into the very same calculus engine, so there's no space for surprises. So now, if you allow me, I think we have reached the end of this very basic demonstration. And now, if you have any more questions about anything that I have shown you now it's your turn to be heard. Okay, we have one question here from Sandeep, and he asks us, can you explain the welded joints instead of bolt joints? Sure thing. I'm sure you're referring to what we have done before in Site Connect Steel, am I right? Great. Let's switch to Site Connect Steel then, and let's see how the welded joints work. I'm going to show you, for example, in this model, or for example, in the other model that we were working with, how the weldings work. In this case, the weldings, as you can see, are already inserted one by one in the order of operation. Each weld can be assigned to an element, and this element can be assigned to another element to which it will be welded. In this case, for example, this first weld is a weld that joins this section V3, into this front plate, into the top flange, and as you can see here, the junction type, we have many different kinds of junction types like fillets and laps, and inside each one we can set different physical properties of each one, like the initial and final displacement and how the fillets are going to be one side or on both sides of the flange, how its projection is going to be like, its width, the thickness, if it's going to be done on factory or if it's going to be done on the construction site, and also how the weld is going to be finished, as you can see here. Okay, we have more questions. Please let me sort through them. Wow, we have many questions right now. Okay. We have a question from, sorry, my screen has frozen. Wait a second. Okay, we have a question here asking, are site structure and site foundation used with the same license? Indeed, when you buy a site structure license, you can either buy a bundle or you can buy individually each program. This you can talk with Vicente later if you want more details, but if you want to create a structure from start to finish, you don't have to buy a license for the structure itself and another for the foundations. If you buy a license for SiteCAD, for example, you have all the basis for the foundations and all the different elements that are built on top of the foundations. Same thing goes for Site 3D. Site 3D also has foundations, albeit not as well defined as SiteCAD, but you could also define the foundations of a project made only with Site 3D, with a license that only covers Site 3D. Okay, let's see more questions. Can CYPE do post-tension analysis? As far as I know, right now, the engine that we use can do this kind of post-tension analysis. And in fact, if you allow me, I'm going to show you how the different forces and different elements of the project that I showed you before work alongside. So let's load the project right here. Okay, there we have it. Now let's switch to the contour maps tab that I was talking about before. We have seen the column definition for vertical elements, the bin definition for horizontal elements, the results to fine-tune the end result of each individual element, and then we have contour maps. That contour maps is what allows us to see exactly the results of the post-tension analysis for each individual piece, just like what we have seen before in CYPE Connect Steel. It's going to take a little while. Okay, meanwhile, I'm seeing more questions. Here's another question that says, is it possible for CYPE and CYPE3D to do bridge analysis? Indeed, there's many bridges that have been built around the world with CYPE and CYPE3D. Let me show you some of them here in the project gallery. Meanwhile, the other project is loading, so sorry for the inconvenience. We have many kinds of bridges that are done, for example, with CYPE. Here we have a kind of bridge for a highway. Or for example, we have something more artistic, like this one, also made with CYPE3D and CYPE. This is a footbridge that is in San Francisco de Moris in the Dominican Republic. And let me show you another structure made with CYPE and CYPE3D as a bridge. For example, this structure right here also works as if it were a bridge. So indeed, you can use CYPE and CYPE3D to calculate, analyze, and design all kinds of structures, including bridges. Back to the question that we were talking about, the stresses. As you can see, the post-stress analysis that we have here can work both with displacements as well as forces. And in regards to forces, we can see each different force that acts on itself, or we can work with different load cases and its combinations. So in this case, for example, we are seeing the total shear on the foundations of the project that I showed you before. But if we wanted to, we could see, for example, a combination on the top floor of the dead weight and the self weight, for example. Takes a little while for it to load. Please be patient. Meanwhile, I'm going to look for more questions. There's a question here from Baxar that says, can we use BS codes? By BS, I'm sure you mean British Steel. Right now, we have many technical codes from all around the world, and indeed we have both technical codes from Great Britain as well as building sections from Great Britain. You can keep in touch with me or technical support at CYPE in case you want to get more into detail of these sections and you would like to obtain them or design your very own by yourself. I'm going to leave right now in the chat my email. We have 20 or 30 minutes more of questions, but in case you have any more questions or you want to keep in touch with us, here's our email. So this is my personal email that I'm going to share right now on chat. And this is the email from my colleagues at the technical support team in case you want to get more into depth with them. Okay, back to the question that we were talking about post-stressed elements. As you can see here, we can check how the different forces and elements interact with each other, both with different kinds of load cases and combinations. So for example, if we were to see with accidental loads, we'll have a quite different view of the contour maps. We also have them with lines like so. So we can see more into deep how they work in each individual element. I hope this tries to clarify as much of your question as possible. Let's see, we have more questions in the panel right here. Okay, here's another question that says, can we decide the still connection designed to full capacity of the member instead of using maximum usage as critical result? I think this is a question in regards to what we did before in CyPE Steel. Indeed, in CyPE Steel, when we did the final analysis, what we have is an analysis in regards to what's the maximum effort that we can put on all the different elements. But in case we wanted, we could look further beyond and instead is stick to even larger sections, or even if we were not in agreement with what the technical code says, we can let it as it is, or even with an even smaller section. In this case, for example, the bolts that I'm using are not up to code, so what I have done is that I've let them by default, and as you can see here in the final comprovation, they do not comply with the technical code. And I'm going to show you also in CYPE 3D, which I've shown at the beginning of this session how it would work like. What would happen in case you were above or under the recommended section for each individual member. As I was saying before, here the bolts, for example, do not comply, and I left them as it is, and I could export this check report with no problem whatsoever. Just that instead of showing a tick, it shows a cross saying that it does not comply. But we can override that. There's no problem whatsoever. And here in CYPE 3D, for example, let's go back to the project that I showed before. Let's see what happens when you either decide to have a section smaller than what it's recommended, or if the sections that you're using are not enough and you can go to an even higher section. If we go to check elements, you will see that, for example, there's ones that are showing now in green and others in red. I've been able to export this into Beam Server Center, even though I have some elements that do not comply. As you can see here, for example, this beam here, the resistance use is above what it's recommended. But if I want to, I can override that and let it as is, or even set it at an even smaller section, like so. Just by double clicking it in it sets it to be an even smaller section. Before it was an IPE 600, and right now it's an IPE 450. So there's no problem with that. I hope that covered your question. Let's see if we have any more questions right now. Okay, we have another question here that says, hi David, I would like to know if CYPE can do an analysis on a composite structure. My case would be of a composite of lightweight steel wall frame and then cast into concrete. Indeed, you can do an analysis that is made with a composite structure, and you can do that with two different ways. The first way is just like I've shown you here in this demo with CYPE 3D and CypCAD. If you have a steel structure that is resting on top of a concrete structure, you can import that with the here in the beam definition with the integrated structures ability here, and you can import your structure, for example, if you have made it in steel here in CYPE 3D, or in case you are referring, for example, with slabs that are made with composite elements. You can also have slabs that are made with steel and concrete. I'm not talking about reinforced concrete, but I'm talking about composite elements like, for example, a steel section in an omega shape, for example. If you go here to slabs in the panel manager, you will see that we can either define the panel, for example, with composite slabs here, with deck or composite deck. We have some preloaded, as you can see here. Or in case your exact solution doesn't exist, you can create your very own here with the Create tab, or you can create a custom definition here in awaiting definition. I hope this has solved your question. Now let's see if we have any more questions pending. Can CYPE do roof analysis? Yes, CYPE can do roof analysis, and that can be done if you put a beam with an inclination. As you can see here, we have the option to put slope beams. And when you put a slope beam, what you have to do first is to define a plane on which it can rest. So to define a plane, we have to first go to here, define rectangular edge, like so. But for brevity's sake, what I'm going to do is I'm going to show you a project that already has a roof in a slope, so you can get a rough idea. Sorry, I'm going to take a little long to look for it. It's a very old project, but it will be worthwhile. Okay, here we have it. Now I'm going to switch to the 3D view so you can see how this option to insert slope beams works. As you can see here, we have a sloped roof, and all these beams are the bounding elements that are used to define all the different slopes of this roof. And indeed, all the loads that are going to fall on top of this roof are going to be calculated both for the slab, which defines the slope, as well as all the beams that define the bounding elements of this particular roof. I hope this has solved your question. In case you have more questions, we still have enough time, so let's see. I'm having some technical difficulties, so I'm sorry for any inconvenience that you may have experienced. Can CypCAD or Cype3D do water returning structure design? Yes, if you use CypCAD to do your foundations, for example, in this project, you will see that we have a wall that is a basement wall, and this basement wall, if I were to edit it, if I go to walls edit, you will see that I can configure it here in the pressure diagrams to have a water table. Let's edit this pressure diagram, for example, or let's add a new one. And as you can see here in the pressure diagrams for this retaining wall, you can set if it has a water table, and you can set up to which elevation it arrives. You can also set the kind of soil that it is in contact with on the sides. We have some preloaded ones. And in case you wanted to go even more into detail, we have a specific software for this. If you recall correctly, at the beginning of this meeting, I showed you the site menu, and the site menu is a collection of our basic programs for structural needs. And in this case, we have, for example, here, software for embedded retaining walls. I could show you now an example for it. It's going to take a little long, sorry for the inconvenience, but okay, here we have it. I'll show you an example of a retaining wall done exactly with this software called embedding retaining walls that is included in your CYPE menu once you install CYPE in your computer right here. For example, let's see this continuous retaining wall. I have to say that this software is perhaps simpler than what we have seen before, but as you can see, it's quite well detailed, and it's straight to the point to what it wants to achieve. And as you can see here, all you have to do is to set all the different layers of soil that are in contact with your retaining wall, and its specific densities, its heights, the pressure that it's going to have at ground level, and from then on you will be able to analyze it, to check it, just like we did in CYPE or in CYPE 3D. We also have more programs for this kind of solution in BIM Server Center. Here in BIM Server Center, if you look for StruBIM, we have StruBIM Foundations as well as StruBIM Embedded Walls, which are basically the companion for this program that we are working here in the background right now. See, just like we have done in CYPE, we can also do a specific calculation just for this very specific element in case we only wanted to calculate just a retaining wall and not an entire structure. But you could do so exactly the same in CYPE as I've shown you here. I hope this has cleared your doubts. So let me see if we have any more questions pending. We still have some time, so don't worry. Okay, we have here a question that says, how can we model with CYPE PEB structures? PEB structures are not your standard project for CYPE, but we can also design that kind of structures. And in fact, if you go to the project gallery, I'm going to share with you the project gallery here in the chat, so you can take a deeper look with way more time to see the details of each individual case. Here you have it in the chat right now. This is the project gallery, as I showed you before, and here we have many kinds of different structures. For example, we have something that is very out of the standard for CYPE, but which is very doable, and is these kinds of structures that are more meant, for example, for industrial needs, like this kind of funnels that you would see in a factory, for example. This could also be made in CYPE 3D. In fact, this is made with CYPE 3D. Or for example, this holding barrel can also be designed with CYPE 3D as well. As I've said, this is not your standard user case, but all our software can be used by architects and engineers alike. And when we say architects and engineers, we mean engineers that work with things as small as a swing. No joke, we have designed a swing for a playground with CYPE 3D. For things as small as a swing, and for things as very out of the blue, like for example this separator tank that we have seen here, or this structural deposit, and so on. So yeah, you can use both CYPE 3D and CYPE for any kind of structures, and in fact I would personally recommend CYPE 3D to design all these kinds of structures that are more related to processes and engineering and so on. In fact, this metal structure that we're seeing here, this deposit, is made all with thin shells. This is all a function that I haven't shown you, but that is inside CYPE 3D, that it's called thin shells. And this, what it does is that it calculates a finite section in regards to the loads that you apply to it. So I hope this has also cleared all your doubts. As you can see, we're talking with software that's very flexible and very customizable and works with all kinds of scales. We can work with things as small as a playground appliance and things as big as the tallest residential building in the world, as I have shown you. So there's no problem whatsoever. We have projects from all around the world. We have many clients in the Americas, in Europe. We are now getting a foothold in Asia, so we also have quite some examples from Asia. So in case you wanted some more examples, you can keep in touch with me with my personal email. I have shared it here in the chat, or you can keep in touch with my colleagues at technical support, sending an email at support@cype.com. So no problem whatsoever. For PAV, now that I take into account, in CYPE there's a specific recommendation that you could use, and that is when you start defining your element inside CYPE. Let's add a bar, for example. When you add a bar, you have the option to set it, for example, like this one. Sorry if it's taking a little long, but yeah, if you set it, you can set it here as a PEV with different kinds of reinforcements. Here we are setting it at this bar that we are describing as a generic element, but if you want it, we want to set a different layout, for example, with box with bottom plates. It could also be a double welded in box. It could be inside a concrete slab. It could be a half section. Could be a double in box joint or with pattern plates. As you can see, it's quite flexible in regards to all the materials that you can use for these kinds of applications. I hope this has also cleared all your doubts. So let me check once more for the questions. I think we are nearing the end of this meeting right now. Okay. Okay, we have here a very interesting question that it says, when we generate the DWG using CypCAD, how do we change the unit to millimeters? Or is it one-to-one scale when we export it to AutoCAD? Okay, when you generate your drawings, you have the option to generate the drawings with a specific scale. In fact, all the drawings that I have shown you are at scale 1:50, and the program automatically sets a size for the page so it fits all your drawings inside. So for example, if I were to generate a drawing for this structure right here, or for example, this other one, this very simple one, if I were to generate the drawings, you will see here that I've already generated some that have a scale that can be easily customizable. For example, here I'm going to generate floor plans, and here I can set the scale. For example, the scale that I'm using right now is 1:50, but if I wanted to, I could make it a 1:1 scale, or if I wanted it, I could put a non-standard scale, like for example 1:125. It's very flexible, as you can see. And if you put a scale that it's not 1:1, the program will automatically select which kind of paper size can hold this drawing automatically, and it will automatically composite all the drawings for you. Let's see, for example, here what it would look like. I'm going to draw all the drawings, and as you can see, because I've selected a very small scale, a 1:125, it tells me that it is a drawing to scale, and the drawing fits on an A4 quite easily. Now, let's say that instead of working with a 1:125, I wanted to work with an even bigger scale, like 1:50. Well, all I have to do is edit here my floor plans, and let's put an even bigger scale, for example, 1:50, like we have said before, or even 1:25, if we wanted that much level of detail. Now let's generate the drawings once again. And once we have it, you will see that it asks us if we want to keep the previous composition, or if you want to make a new composition. Let's say no, because I'm sure that the drawings will be way larger. And as you can see, indeed, now instead of fitting the same drawings in an A4, we now have an A1. And if we draw all the drawings, you will see that now it says that the scale is 1 to 25. And if I were to export it into a DWG file, it would be exactly the same. If I were to measure the units would be millimeters, but real millimeters on the paper. So in this case, if I'm using a 1 to 25 scale, and this, for example, measures, I don't know, 1 meter, this would measure the inverse in millimeters. That would be maybe 25 millimeters. Sorry, 25 centimeters. 25 centimeters. Or 250 units, because normally when we export to DXF, 1 unit equals 1 millimeter. Okay, we have more questions. We have, I need to design one steel chimney foundation. I intend to use a finite element method. Can you show how to generate finite element in CYPE? I am very familiar with StatPro, but I'm not very clear with CYPE. Okay, in regards to the finite element with CYPE, you could do two things. You could either work directly into CyPeCAD, and in CyPeCAD create a foundation, or if you wanted to, you could go directly into Site3D, because Site3D, I show you directly how it works in conjunction with Site Steel. But in case you don't want to go that much into detail, Site3D also has preloaded some junctions, some unions that are calculated automatically with the finite element method. Let me show you an example. For example, let me look for it. Okay, here we have a more industrial building. We have a warehouse, and this warehouse, all the unions have been generated inside Site3D, because Site3D already has them preloaded. You can buy also the unions pack, so you can automatically generate all these kinds of unions without switching to CyPE Steel, either with welds or with bolts. Let's see, for example, in the 3D view, how these unions work. Project tools, 3D view, complete structure. As you can see here, these unions have not been designed by myself, but instead what I have done is that once I have all the different elements of this structure defined, what I do is that I automatically generate the unions, and then I can check if all the unions comply with the technical code. And if only if I'm not completely sure that I like the result that Site3D has given me, I can either go one by one and fine tune a little bit inside Site3D, or I can export it into CyPE Steel and then design a very customizable union just for that project. I'm going to show you how we can edit these kinds of unions here. As you can see, all the unions have been generated. So if I go to edit, and let's edit, for example, this union, type 57, you will see that it has been calculated just like if we have done it by hand in Site3D. And you can see all the different comprobations that it's not complying in this case. For example, we have two incidents here that if you wanted to, we could here design. I'm going to redesign, sorry, this union again. Connection method, for example, all with welded connections, and I'm going to use the define configuration for this job. The internal engine treats all the welds and all the unions as finite elements, so it will automatically generate this union accordingly to all the efforts or the strains. And as you can see here, you get your final results stating how everything has been calculated in regards to the finite elements method, with all the internal verifications and so on. And you can see for each element which code checks have been applied and which ones have failed, like this one, for example. So I hope this has cleared your questions, and in case you have any more questions, you can always keep in touch with me through the email address that I have shared here in the chat, either directly to my email address or to my colleagues in the support department. Okay, let's see if we have more questions right now. We are nearing the end of this meeting, so I'm trying to be very quick right now. Okay, we have how can I integrate the architecture with the structure with CYPE? Okay, let's say that you have started developing your project with CYPE architecture or with another program that allows you to export IFC files. What you have to do is, for example, with CYPE architecture, once you have your model all already designed, like so, with your vertical elements, horizontal elements, and so on, you link it to your project. Here, you export first an IFC file. I'm going to do this very briefly here. You generate an IFC file, and then you upload this IFC file to your project here with the update button. Once you have updated it, when you start a new project here in CYPE, for example, let's start a new one so you can see it. You will see that it asks us if we want to import a BIM model, because we have already designed it with CYPE, with CYPE architecture, or with any other program that allows us to import and export IFC files like this one right here. See, it's an IFC file. We can continue clicking yes, and then following all the steps to link it to our project, which contains our IFC file. Here I have the project that contains the IFC file for this building right here that I've modeled in CYPE architecture. And then what I have to do is to follow all the steps inside this assistant, so all the elements are imported accordingly. As you can see, you can import the floor plans, you can set all the different columns, you can also export only the outlines of the floor slabs in case you want to change the orientation or the alignation between all the different floors of your building, in case you wanted to make a floor slightly larger than what you have, for example, here in CYPE. Sorry, in CYPE architecture. So yeah, as you can see, it's as easy as exporting an IFC file of your architectural model, be it with CYPE architecture or with your favorite architectural modeling software. Then upload it to your project here in BIM Server Center. And once you have it in your project in BIM Server Center, you start a new project here in CYPE. And when it asks you if you want to import a BIM project, all you have to do is click yes and follow the steps here. Okay, I hope that's enough for that question. One last question, and we will be finishing right now our meeting. Okay, let's see. Okay, our last question. If I design a structure with concrete, can CYPE show the automatic rebar? Indeed, CYPE and CYPE 3D both generate automatically or your rebar. And let me show you, for example, here, this project that I have here already calculated. I have already with the results how the river works. Let's switch to the results tab, and you will see exactly for each element how the river works. For example, if I go to the upper floor and I click here on beams, walls, edit, sorry, let me try with another project. Let's try with the one that we were talking about before, the one that we have been treating for this whole meeting. Okay, this project is already analyzed, so we can switch to the results tab. And once we get to the results tab, we can see how each river has been designed for every element. So for example, if I were to go to, for example, beams, let's go to the upper level. Let's select the beam, beams, walls, edit beams. Let's select this one, for example. And now we'll get a new window, which tells us exactly how the program has designed all the different reinforcement with rebar. See, here we have all the reinforcements with its lengths, its anchor lengths, diameters, and so on, and how the sections would look like in each part of the continuous beam. As well as you can see why each element has been designed in regards to the efforts that it is resisting against, like the shear efforts, the shear wall, sorry, the shear forces, and so on. And in case you are not content, in case you believe it's not enough what the program has calculated, you can always add more rebar here with longitudinal reinforcements like so. Right now I'm adding here more rebar to this section, to its upper section, and I'm using this section here. And in case I want to use a different diameter, I can select from these lists, and this list will be automatically configured once you select your technical code. So for example, let's say I want to make it even larger, like, I don't know, T32. Once I have it, I can check here if it complies with the reinforcement area graphs. It is already compliant. And now I can rebuild the structure, or I can go for its individual check. In this case, I'm going to update the information for the errors. And I'm going to see if this rebar that I have added is enough or if I could get rid of it. Okay, the program shows no errors right here. And if I go here to rebuild, I will be able to see if I need additional reinforcement in the traverse or longitudinal reinforcement rebars. Okay, now we have our beam already reanalyzed, and if we go to here the checks, we will see that indeed each individual element has enough rebar. And you can see all the criteria that has been applied to get the dimensions, the lengths, the anchor lengths, the diameters, and so on. See? And this will also be exported when you generate your drawings. You can generate drawings specifically just for your rebar and the reinforcements and so on. In this case, I believe I've done this for the columns, so let's see how it will look like in the columns. Okay, accept. And now let's see the drawings that the program has already generated and the rebar that how it should look like once we put it into the construction site. Sorry if it's taking a little longer. This will be our last question because it's now the end of our meeting. So if you have more questions, you can ask right now Vicente, who's also joining us today, or you can send any more questions directly to us, either to my personal email inside the company or to my colleagues at the technical support department. Okay. Yes. And now we have here all the drawings. Let's draw, for example, this is the detail of a column. And as you can see, we have the drawings of how the rebar should be set in the construction site with all the dimensions, diameters, lengths, dispositions, unions, and so on. You can also have, as you can see here, a little quantities tab with a simple diagram of each different element and its properties, length, weight, position, diameter, number of pieces, and so on. Okay, so I hope this webinar has been useful for all of you, that you have seen some purpose in all the demonstrations that I have shown you, that you make a great use of the licenses that we're going to give you temporarily for this following month, and don't hesitate to keep in touch with us, to ask us as many questions as you want, either in regards to the program and pricing, or in its usage, or even in projects that you are developing right now, because we have technicians that could ask, that could solve all your questions in regards to design itself, not only in usage of the programs and in errors and so on. Vicente, are you joining us?
Yeah. Hey, David.
So I was saying that right now we have ended our allotted time for this meeting. So in case you wanted to have any closing remarks.
No, I think it's okay. It was a very nice presentation. Thank you very much, David. Yeah, the same you said now. Any questions? You have the email of David in the chat, so don't hesitate to contact us. Okay, and well, we will maybe organize another series of webinars regarding structures, and we will keep you updated. And also, any suggestions you may have or any topic you would like to talk about, feel free to send it to us, and we will do it. Okay, David, thank you very much. Thank you,
Thank you
everybody.
very much.
See you next time.
Have a nice day.